Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video, I will explain the trigonometric form of a non-zero complex number. Also, I will give you some rules in trigonometry. Write in trigonometric form each of the following complex numbers. Remember that the trigonometric form of a complex number is z equal modulus of z cosine alpha plus I sine alpha. Modulus of z different from 0, it is positive. Modulus of z is the length of OM. Length of OM. And remember that modulus of z equal radical x square plus y square, where x and y are real and imaginary of z. Cosine alpha, alpha x prime x OM equals alpha plus 2k pi. The angle between x prime x and OM is alpha plus 2k pi. Z1 equal minus 3 cosine alpha plus I sine alpha. This is not the trigonometric form of a complex number because here we have minus 3 negative. How to get rid of minus? We introduce minus inside the brackets. We get 3 into minus cosine alpha minus I sine alpha. How to get rid of minus in such a way we get cosine angle plus I sine same angle? We know that in the third quadrant cosine pi plus alpha and sine pi plus alpha equals minus cosine alpha and minus sine alpha. So this is cosine pi plus alpha plus I sine pi plus alpha. And modulus of z1 equals 3 positive, and the argument of z1 is pi plus alpha plus 2k pi. Pi plus alpha plus 2k pi. Or we say pi plus alpha is an argument of z1. Another example. z2 equal 3 into minus cosine alpha plus I sine minus alpha. In this example, 3 is a positive. No matter about 3 here. There is a problem here in minus cosine alpha. Minus cosine alpha. So how to get rid of minus cosine alpha? And you write cosine of an angle plus I sine same angle. We know that in the second quadrant cosine pi minus alpha equal minus cosine alpha and sine pi minus alpha equal sine alpha. So this is cosine pi minus alpha plus I sine pi minus alpha. Then positive number cosine angle plus I sine same angle. This is the trigonometric form. Modulus of z2 equal 3 and an argument of z2 is pi minus alpha. z3 equal 3 cosine alpha minus I sine alpha. In this case we have to get rid of minus here before I sine alpha. So how to get rid of this minus? We know that in the fourth quadrant cosine minus alpha equals cosine alpha and sine minus alpha equals minus I sine alpha. So this is cosine minus alpha plus I sine minus alpha. Cosine minus alpha equal cosine alpha, sine minus alpha equal minus sine alpha, so we go back to z3. This is the trigonometric form of z3 because here we have positive number cosine angle plus I sine same angle. Modulus of z equal 3, argument equals minus alpha plus 2k pi. An argument is minus alpha. z4 equal 3 sine pi by 3 plus I cosine pi by 3. We should have here cosine angle plus I sine same angle. We know that sine pi by 3 is cosine pi by 6. Sine pi by 3 equals how much? Equals radical 3 over 2. This is cosine pi by 6. And cosine pi over 3 equals sine pi by 6. Then this is the trigonometric form of z4. Modulus equal 3 and the pi by 6 is an argument of z4. Z5 equals 3 sine alpha plus I cosine alpha. Here we have sine alpha, not cosine alpha. So how to change sine alpha into cosine alpha? We should have positive number into cosine angle plus I sine same angle. We will see. Follow me to see how to transform sine alpha into cosine alpha and cosine alpha into sine alpha. First cosine A minus B. How to calculate cosine A minus B? Cosine A minus B, this is angle A and this is angle B. And here we have the trigonometric circle. The coordinates of M are cosine A, sine A, and the coordinates of N cosine B, sine B. Remember the scalar product of two vectors. The abscissa of vector OM is x of M minus x of O equal x of M minus 0. The ordinate y of M minus y of O. The ordinate of O 0, so y of M. Then cosine A, sine A. ON cosine B, sine B. The scalar product of OM and ON. OM dot ON. OM dot ON equals x prime plus y prime. X prime plus y prime, scalar product of two vectors. So cosine A times cosine B plus sine A sine B. Also we have another rule for the scalar product of two vectors. OM dot ON equals modulus of OM times modulus of ON, cosine angle ON OM. Cosine ON OM. The angle between ON and OM is A minus B. So, and OM equals ON equal radius equal 1, trigonometric circle, 1 times 1 times cosine A minus B equals cosine A minus B. OM dot ON here and OM dot ON here. So, by comparison, cosine A minus B equals cosine A cosine B plus sine A sine B. What about cosine A plus B? Cosine A plus B equals cosine A minus minus B. This is cosine A, cosine minus B, sine A, sine B. The same rule, but instead of B, we have minus B. The same rule. We substitute B by minus B. Cosine B is cosine B. Cosine minus B is cosine B. Cosine B is minus cosine B, but sine minus B equal minus sine B. We get cosine A plus B equals cosine A cosine B minus sine A sine B. Now we are going to study the symmetric of a point with respect to the straight line of equation y equal x in order to know the rules which transform sine into cosine. Symmetric of a point with respect to y equal x. Y equal x is called the first bisector. The first bisector. Y equal x, it is the straight line passing through the point of abscissa 1, ordinate 1. Abscissa 2, ordinate 2. So this straight line passes through the points where the ordinate equals to abscissa. This straight line passes through all the points 1, 1, 2, 2, 3, 3, 4, 4, minus 1, minus 1, minus 2, minus 2, 0, 0, etc. Let us see this straight line. Here, this is straight line. Y equal x. Y equal x passes through the points 1, 1, 2, 2, etc. called first bisector. Why first bisector? Because it is the bisector of this angle. This straight line is the bisector of angle OX or OY. This angle here equal to this angle. For this reason, this straight line is called first bisector. Let M26 the parallel from M to y prime y cuts the first bisector at P. Since MP parallel to the y-axis, then P and M have the same abscissa. The abscissa of M is 2, then the abscissa of P is 2. The ordinate of P is 2 because y equal x. And you will see graphically the coordinates of P, 2, 2. The parallel drawn from M to x-axis. If we draw the parallel here, all the points belonging to a horizontal line have the same ordinate. So this straight line cuts the first bisector at Q. The ordinate of Q is equal to the ordinate of M. Q and M have the same ordinate. Then Q of ordinate 6, y equals 6, x equals 6. And you will see the coordinates of Q also graphically. Q 6, 6. Complete the parallelogram PMQN, PMQN. And since MP equals MQ equals 4, count 4, 4. This triangle is right isosceles. And we have a parallelogram here. PMQN is a parallelogram. Then this quadrilateral is a square. Why is a square? Because this side equal to this side, right isosceles triangle. And we know that the opposite sides in a parallelogram are equal. So all the sides are equal, having an angle 90, then it is a parallelogram, it is a square. We know that in a square the diagonals bisect each other, and then the y equal x, the first bisector is the bisector of segment MN. It means N is what? Is the symmetric of M with respect to first bisector. And what are the coordinates of N? The abscissa of N is 6, and the ordinate is what? Is 2. The abscissa of N is the same as the abscissa of Q, 6, and the ordinate of N is the ordinate of what? Of P. All the points belonging to a vertical straight line have the same abscissa. All the points belonging to a horizontal straight line have the same ordinate. Then N of coordinates 6, 2. 6, 2. M 2, 6 and 6, 2. They are symmetric with respect to the first bisector y equal x. So if we have the point of coordinates 7, 4, what are the coordinates of the symmetric of this point with respect to the first bisector? 4, 7. We change x into y and y into x. So MPQN is a square, and the point N is the symmetric of M with respect to y equal x, which is the first bisector. In general, N is 6, 2. In general, the symmetric of AB with respect to y equal x is the point B of coordinates BA. So we change the x into y and the y into x. Draw a figure to be sure that your result is correct. Now we are going to transform cosine pi by 2 minus alpha and sine pi by 2 minus alpha into cosine alpha and sine alpha. Let us see. MOA equals alpha, NOA equals pi by 2 minus alpha. Locate M and N on the trigonometric circle. This is the trigonometric circle. Then this angle is alpha. We delete alpha from here, then this arc is pi by 2 minus alpha. The coordinates of M are cosine alpha, sine alpha. The coordinates of M, cosine alpha, sine alpha. And the coordinates of N, cosine pi by 2 minus alpha, sine pi by 2 minus alpha. The coordinates of M, cosine alpha, sine alpha, and the coordinates of N, cosine pi by 2 minus alpha, sine pi by 2 minus alpha, since this angle is how much? Pi by 2 minus alpha. Pi by 2 minus alpha. Draw the bisector of the angle NOM. Bisector of this angle. The bisector of this angle cuts MN into the point I. Then here we have a bisector of angle OMN. The triangle ONM is isosceles at O. The bisector is at the same time perpendicular bisector of segment MN. It is height, it is median, because the median relative to the base, or the bisector relative to the base, is everything. Height, bisector, median. So angle NOI equals angle IOM. Here we have, for example, beta, and here we have beta. These two angles are equal, beta. Also we have M and N are symmetric with respect to OI. M and N are symmetric with respect to OI. But in fact, here we have beta plus alpha, and beta plus alpha from the other side. Beta plus alpha and beta plus alpha. We conclude that the bisector of angle OXOY, which is the first bisector. OI is the first bisector. Then the coordinates of N should be what? The coordinates of M, cosine alpha, sine alpha. The coordinates of N should be sine alpha, cosine alpha. So here we have sine alpha and here cosine alpha. What do we conclude? Cosine pi by 2 minus alpha equals sine alpha, and sine pi by 2 minus alpha equals cosine alpha. And the symmetric of M with respect to Y equal X. So cosine pi by 2 minus alpha equals sine alpha, and sin pi by 2 minus alpha equals cosine alpha. Rules of sine A minus B and sine A plus B. We know that cosine A minus B equals cosine A cosine B plus sine A sine B. And cosine A minus cosine A plus B equals cosine A cosine B minus sine A sine B. If we have a plus, in the other side we have minus. If we have minus, we have a plus on the other side. Remember that sine pi by 2 minus alpha, cosine pi by 2 minus alpha equals sine alpha, and sine pi by 2 minus alpha equals cosine alpha. Sine A minus B equals cosine pi by 2 minus A minus B. We know that cosine pi by 2 minus alpha equals sine alpha. Or sine alpha equals cosine pi by 2 minus alpha, the same. Pi by 2 minus a minus b. So this is pi by 2 minus a plus b. Pi by 2 minus a alone plus b. Because in cosine we have a plus, here we have minus. So then cosine pi by 2 minus a, which is sine a, sine pi by 2 minus a equals cosine a. So this is sine a cosine b minus cosine a sine b. What about, so the rule is sine a minus b equals sine a cosine b minus cosine a sine b. Sine a plus b equals sine a minus b. Minus plus. Then we use the rule of sine a minus b, but instead of b we have minus b. Then this rule is sine a cosine b, the same as sine a minus b, but instead of b we have minus b. Sine a cosine minus b minus cosine a sine minus b. But cosine minus b equals cosine b, and sine minus b equals minus sine b. Then minus plus. Sine a plus b equals sine a cosine b plus cosine a sine b. Thanks for following and good luck.